Hello guys, we're gonna talk about the solution of a complex gas power plant. This is the same problem that we saw in class, so we are going to show the complete solution. First of all, we are going to start with our diagram, and in the diagram we are indicating all the components, the two compressors and two turbines, the reheat section and the heater section, and the regenerator. First of all, the problem doesn't only tell us that P1 is 100 kilopascal and total pressure, the difference that the P4 is 1200, but it doesn't tell us what is the intermediate pressure. So we don't know which the value of P2, but we know that in order to have the maximum efficiency, P2 over P1 should be equal to P4 over P3, and P6 over P7 should be equal to P8 over P9. If we solve this, P2 will be the square root of P1 times P4. This will be the same as 346.4 kilopascal. So P2 will be equal to P3 and should be equal to P7 and P8. Also P1 equals P9, 100 kilopascal, and P4 equals P5 equals P6. So we know all the pressures. We're starting from the top. We know the backward ratio will be the work of the turbine, the work of the compressor over the work of the turbine. This time we have two turbines and two compressors. Later on we are going to find out this value. And the efficiency notice that this work of the turbine we already finding in the backward ratio. Same for the work of the compressor, and the Q in is the summation of the heater, and the reheater. Now, applying first law, we can find the following expressions. If you don't remember how do we got this expression, go back into your notes or perform a first law analysis for each of the compressors, starting from the general expression and eliminating what is not needed. We can notice that we need to find state 5, and in order to find state 5, when I use the definition of effectiveness, and effectiveness can be computed as actual heat H5 minus H4A divided by the maximum heat H9A minus H4A, and this value is 0.75. From here we can get value of H5. So we already solved. This is the analysis. Next we're gonna find out each state. So finding a state, we're going to use table A17 or the table that you have in your in Blackboard to do the interpolations. So we start with state 1. We know that temperature 1 is equal to 300 Kelvin. From there we can get enthalpy 1, 319 kilojoules per kilogram, and we can get PR1. PR1 is 1.386. Now, to get state 2s, we use the psychometric, the isotropic process. You can see it here, and we solve for PR2. So PR2 is 4.801. By interpolation, we can find H2, and since we use an isentropic process, is H2S equal 428.17 kilojoules per kilogram. Now, since we have an isentropic efficiency of the compressor, it can be defined as H2S minus H1, H2A minus H1 equal to 0.8. By solving this, we can get that H2A of 460.17 kilojoules per kilogram. Repeating this for state 3, we know that temperature 3 is 350 K, so H3 equals 350.49 kilojoules per kilogram, and PR3 is 2.37, no units, remember. So now we're going to find out state 4S, and to do that, again, we'll start with our isentropic relation. So this, using the same isentropic relation, we get a value of PR4 of 8.241. So by interpolation, we can find that H4S, since we use isentropic expression, is 500.043. 0.04 is okay. Using the same definition of the isentropic compressor, we can get that H4A is equal to 537.9 431 kilojoules per kilogram. We're going to skip state 5 until we get to state 9, and this comes from the definition of effectiveness. We need to find H9 in order to get H5. So we'll start with state 6. On state 6, we know that the temperature is 1400 Kelvin. From there, we can get H4 to be equal to 1515.42, and PR4, sorry, this is 6. PR6 is 450.5. Again, no units. We know that to get state 7S, we're going to use again our isentropic process. So here we have our isentropic relations. We are using exactly the same as we did for the compressor, and we already captured that P7 is the same as P3, 346.4. That gives us a PR of 130.5. By interpolation, we get 1082.88 kilojoules per kilogram. And now to get state 7A, in order to get the actual state, that is 7A, we use the definition of the isentropic efficiency of the turbine to be H6, and by solving to H7A, we got 1069.97. Remember that the efficiency of the turbine again is 0.8. So we can repeat the same procedure for the second turbine. So we start by our isentropic relation. We solve to get PR9 to be 95.25, 0.523, and then by interpolation we find the value of H9S. Using the definition of the isentropic efficiency for the turbine and knowing that the value is 0.8, we can get the value of our H9A. Now we have H9A, so we can come back here to find the value of state 5. So in order to find state 5, we remember that the effectiveness is the actual heat that we are getting divided by the maximum heat that we could get. We know that this is 0.75. So solving for H5, we get that H5 has a value of 941.49 kilojoules per kilogram. With this, we have all our states, and we can go back and substitute in our first slide. So you can do all the math and just putting the total values. So as we mentioned, you can do all the math because you know the values, and these are the individual values for the compressor work 1 and 2. So the total compressor work will be 346.92. We can also get the total turbine work to be 665.75, and the total value of Q in to be 800.43. So if we substitute in these expressions, we get that the backward ratio is 52.11. In order to get the efficiency, we already compute the total heat in, but we don't have the net work, which will be the difference between work of the turbine and work of the compressor, just express it here. And this value, it's going to be 318.83. This gives us an efficiency of 39.83%. Notice that the values we got are very close for the heat in, not the same for the efficiency. We're going to stick to our numbers since backward ratio means that we have right the Q, the work net, and the work of the turbine and the work of the compressor, same for the net work. So since we know that our calculation of heat in is correct, we're going to stick with our value of 39. Okay guys, I hope that this is clear and that you understand how to analyze these cycles. Thank you very much.